IIT Guwahati develops 3D printing technology which can cut concrete use by 75%. Kerala gets its first ever scientific bird atlas, and physicists detect exotic particles in Quark-Gluon plasma. I'm Nidhi Kumar and you're watching Science Time, a show that brings to you the best that science offers, from exciting developments in science and technology to futuristic solutions. And let's look at story number 1. Well, researchers at IIT Guwahati have manufactured 3D printing urban furniture using local industrial waste to make construction materials. They have also developed cementitious mix of compositions amenable for 3D printing. This innovation is said to be able to cut down concrete use by 75%. The IIT Guwahati researchers utilized a specially developed printable concrete containing industrial waste as binders to manufacture 3D printing furniture. The manufactured piece had a height of 0.4 meters, a width of 0.4 meters, and an arch-shaped support that was modeled and sliced using SolidWorks and Simplified 3D respectively. Each layer had a 10 mm height, and the complete unit was printed layer by layer at an 80 mm pace. Before being utilized, the unit was wrapped in wet gunny bags for 7 days to cure after printing. The concrete printer was jointly developed by IIT Guwahati and Detsays E-Forming and can print components up to 1 meter long, 1 meter wide and 1 meter tall. The jointly developed 3D printer completed the cycle for the urban furniture in about 20 minutes. The team behind the research believes that the on-demand, on-site 3D concrete printing will definitely have a global impact on versatile construction applications and the multi-billion-dollar markets worldwide. The team wants to explore underwater concrete printing and the possibility of printing functional reinforced concrete using low-carbon materials. This research is being supported by the Department of Science and Technology. And let's move on to story number 2. Kerala gets its first ever scientific bird atlas. The Kerala Bird Atlas is first of its kind state-level bird atlas in India and has created solid baseline data about the distribution and abundance of the various bird species across major habitats, giving an impetus for futuristic studies. Conducted as a citizen science-driven exercise with the participation of over 1,000 volunteers of the bird watching community, KBA was prepared based on systematic surveys held twice over 60 days in a year during the wet July to September and dry January to March seasons between 2015 and 2020. KBA accounted for nearly 3 lakh records of 361 species, including 94 very rare species, 110 common species, 44 very common species, and 10 most abundant species. It is arguably Asia's largest bird atlas in terms of geographical extent, sampling effort, and species coverage derived from the aggregation of 25,000 checklists. It was found that the species count was higher during the dry season than in the wet season, while species richness and evenness were higher in the northern and central districts than in the southern districts. Most of the endemics were concentrated in the western Ghats, while the threatened species were mostly along the coast. The KBA is considered to be a valuable resource for testing various ecological hypotheses and suggesting science-backed conservation measures. And let's take you to story number 3. In the first millions of a second after the Big Bang, the universe was a rolling trillion-degree plasma of quarks and gluons, elementary particles that briefly glommed together in countless combinations before cooling and settling into more stable configurations to make the neutrons and protons of ordinary matter. In the chaos before cooling, a fraction of these quarks and gluons collided randomly to form short-lived X particles, so named for their mysterious unknown structures. Today, X particles are extremely rare, though physicists have theorized that they may be created in particle accelerators through quark coalescence, where high energy collisions can generate similar flashes of quark-gluon plasma. Now, physicists at MIT's Laboratory for Nuclear Science and elsewhere have found evidence of X particles in the quark-gluon plasma produced in the Large Hadron Collider at CERN, or the European Organization for Nuclear Research based near Geneva, Switzerland. The team used machine learning techniques to sift through more than 13 billion heavy ion collisions, each of which produced tens of thousands of charged particles, and amid this ultra dense high energy particle soup, the researchers were able to tease out about 100 X particles of a type known as X3872, named for the particle's estimated mass. The results, published in Physical Review Letters, mark the first time researchers have detected X particles in Quark-Gluon plasma, an environment that they hope will illuminate the particles' as yet unknown structure. The findings could redefine the kinds of particles that were abundant in early universe. And with this, we come to an end of this edition of Science Time. We'll be back with more interesting stories from the world of science next week. Until then, stay tuned to India Science. Namaskar. Thank you for watching.